Hello everyone. Thank you for joining me today. The global hydrogen economy is scaling fast, and electrolyzer factories are at the core of this transformation. According to the International Energy Agency, as of early 2025, global electrolyzer manufacturing capacity stands at approximately 25 gigawatts per year. Moreover, the IEA reports that this announced manufacturing capacity or the potential to build electrolyzers is expected to significantly scale up, with projections indicating that global electrolyzer manufacturing capacity could exceed 165 gigawatts per year by 2030. Yet, one of the most overlooked and potentially business-defining factors in setting up an electrolyzer manufacturing factory is the power supply and grid connection strategy. Since electrolyzers are highly energy-intensive, securing reliable, cost-efficient electricity access determines both short-term feasibility and long-term competitiveness. Each electrolyzer unit would require factory acceptance at full capacity, and sometimes you may have more than one unit running in parallel. Some units may be running for troubleshootings, so it is extremely important the factory has a large electricity connection. Electrolyzers consume vast amounts of electricity, 45 to 55 kilowatt-hour per kilogram of hydrogen produced. A factory running multiple test units simultaneously may require peak loads far beyond typical industrial demand. This makes energy planning a cornerstone of the electrolyzer factory business case. Forecast not just today's consumption but the future scalability needs of the plant, testing, parallel runs, and expansions. Negotiate long-term power purchase agreements to protect against market volatility. Electricity is often the largest operational cost, so predictable pricing is critical for profitability. Grid fluctuations, outages, or poor power quality can affect electrolyzer performance. Grid access is often a bottleneck. Distribution network operators typically face significant application backlogs, and approvals can take months or even years depending on location and available capacity. Joining the queue early secures a better position and reduces risk of costly delays. Confirm whether the local substation can handle peak load requirements. If not, reinforcement costs may fall on the factory project. Beyond approval, installation and commissioning can stretch timelines further. This must be factored into overall factory project scheduling. Provides stable access to power, but comes with transmission and distribution charges. Bypasses grid fees and can save 40 to 50% in transmission and distribution costs. However, securing dedicated off-grid supply is often difficult due to limited availability and regulatory hurdles. Combining grid connection with on-site renewable generation, solar, wind, or storage, provides resilience, cost savings, and enhances the sustainability profile. Each electrolyzer unit requires full capacity testing before deployment. Running multiple factory acceptance tests in parallel or troubleshooting existing units demands large, flexible electricity connections. Implement smart load scheduling to optimize electricity use, shifting high-demand operations to periods of lower tariffs where possible. Advanced AI-based energy management systems can help track usage, predict peak loads, and automate demand-side adjustments for efficiency. Beyond the basics of power supply and grid connection, several strategic moves can enhance competitiveness. Where possible, source renewable electricity. This strengthens ESG credentials and improves access to green financing. Design the electrical infrastructure for modular upgrades, accommodating next-generation electrolyzers or expanded test bays without major overhauls. Early, transparent collaboration can sometimes unlock shared infrastructure investment, reducing costs and delays. Simulate factory energy demand under different scenarios, multiple units, downtime, peak runs, to optimize both CAPEX and OPEX. Setting up an electrolyzer factory is not just about assembling technology, it's about engineering the power ecosystem that sustains it. A well-planned power supply and grid connection strategy can make a big difference. By securing long-term energy agreements, entering the grid queue early, considering hybrid or off-grid solutions, and planning for operational flexibility, electrolyzer factory business can significantly enhance productivity, reduce risk, and position themselves strongly in the emerging hydrogen economy. Thank you very much for your time and watching my video. Really appreciate you sticking around until the end. Awesome. If you found this video helpful, please share it with your friends and give it a big thumbs up. And don't forget to hit that subscribe button so you never miss future videos like this. Got a question or a topic you'd love me to cover? Drop a comment below, I'm always excited to hear from you.